Okay, let's look at 6-2, our 30, 60, 90 triangles. Well, let's again discover our labels like we did on 6-1 with our 45, 45. So let's follow these steps. Draw the height of the triangle. We know that the height shows the altitude. We start at the top vertex and go straight down, creating a right angle. It says what is formed. Well, we know that we have those right angles. We created 2 triangles. We also know that we started with an equilateral triangle. And if we start with an equilateral triangle, we know that all of these angles are 60. Well, when we draw the altitude, it bisects that top one, creating our 30 degrees. And so this is how your 30, 60, 90 is formed. They want us to label the short side X. Well, the short side is always across from the smallest angle. So we go from 30 and we go across. So that's X. And they want us to find all of our other sides. Well, if this short side is X and the altitude cuts these two triangles, or this triangle, into 2 congruent parts, then this is X. So that means the side length would be 2X. So now we have those 2 pieces. And so if we set this up, let me find some room here, and we say x squared plus our b, we don't know what that one is, we've got to find it, equals our 2x squared. Notice I put that in parentheses so that you apply the squared to both the 2 and the x. So we have x squared plus our b squared, and we can square both of those, so we get 4x squared. We want to combine our like terms, so we're going to subtract the x squared over. So now b squared equals 3x squared. Well, we want b by itself, so we've got to square root it. And if we square root this side, we have to square root the other side, canceling that side out. We know that this really looks like 3 times x, giving us a pair. Remember, pairs go on the outside, so b equals x square root of 3. And that's what label goes with the altitude across from the 60. So when we go to do a 30, 60, 90 triangle, we still have a tic-tac-toe board, but this time it looks something like this. We have 30, 60, 90. 30 is going to be across from our small side, so that would always be x. 60 is across from the altitude, so that would be our x squared of 3. And the 90 is the long side, which will always be 2x. So let's talk about some relationships here for a minute. We know that, let me make up a problem here. Let's say that, I don't want to use the same numbers as below. Let's say that x is 5. Okay. We can substitute that 5 in and replace it with, make it 5 squared of 3. We can also substitute that x in here and say 2 times 5, which would be 10, and that would give you all of your numbers. Okay, let's try another one. What if this was, let's say 8? We would substitute in under the 60, it'd be 8 squared of 3. Substitute in for the 2x, and you would get 16. So just that way, we could also reverse it. Let's say I told you this was 12. Well, we know that 2 times what gives me 12. I could go the opposite way and know that that is 6. Always has that relationship. Either we're multiplying by 2 or dividing by 2. And then once you know x, you can substitute in and say 6 squared of 3. So those are the labels I want you to use. Now you have to pay attention to where the 30 and 60 are. So if your 30 is up at the top, then we know x goes here, 60 would go right here, x squared of 3, and our 90 would always be 2x. Or what if they switched it around, put the 30 at the bottom? We still know we go across for x. 60 is x squared of 3, and our 90 is 2x. So set up your tic-tac-toe and plug things in just like we talked about. So let's look at the first one. Let's go ahead and set up our tic-tac-toe. 30 with the x, 60x squared of 3, and 90 with the 2x. Looking at our problem, we know that 14 is across from the 90, so that's where that goes. That was given. So we know that 2x equals 14. You can set it up like this if you need to. Divide by 2, x equals 7. Once you know x, you can substitute in for that x and say that across from the 60 will be a side length of 7 square root of 3. And so now once you get that chart filled out, let's look and see who it's asking for. LM is right here. It's across from the 60, so I go to my tic-tac-toe. Under the 60, I wrote that that would be 7 square root of 3. MN is across from the 30, and so that would be 7. Okay, let's look at another example here. Still a 30, 60, 90, so let's set up our tic-tac-toe. Labels x squared of 3, and 2x. All right, we were given 2 square root of 5 across from this angle, and that one's missing, so we know it has to be the 30. So we're going to put that in place here. Now this one doesn't look as easy as the other one, so we're still going to substitute it in. We'll talk about how to do that. So I'm going to take this whole thing and substitute it in for each x. Okay, so the first one I'm going to do is 60. So we would say 2 square root of 5, that's your x, times square root of 3. 2 square root of 5 went in for the x. Still have that square root of 3. So now we just multiply our like terms. We know that the 5 and the 3 are like terms, so we could say 2 square root of 15. 15 is not going to simplify down, so that would go in under the 60. Now we're going to do the same thing, but substitute the 2 square root of 5 in for the x here, and say 2 times 2 square root of 5. Our like terms here are the numbers on the outside, and so 2 times 2 would be 4, square root of 5, and that would go under the 90. Just squeeze that to the side. So now that we have our chart filled out, we can look and see who they're asking for. LM is across from the 60, so I go to my chart. I wrote that that would be 2 square root of 15. LN is my hypotenuse, that's across from the 90, and that would be 4 square root of 5. Okay, let's do a couple more just to get this practice in. This one's a little bit, a few more steps in the 45-45. So it's a 30, 60, 90. So let's set up our tic-tac-toe. Okay, I was given 8 across from the 60, so that's what I'm going to put there. That was given. That doesn't look like it's supposed to. So when we get that situation, we're going to set up an equation. We're trying to solve for x, so we divide by the square root of 3. We're not supposed to leave a radical in the denominator, so we have to rationalize like we did before. Okay, multiply straight across. Those are not like terms, so all we can do is set them side by side. We know we multiply the same thing by itself. It gives us that number under the radical. We cannot simplify 8 over 3, so that becomes our x. Now we're going to take all of this and we're going to substitute it in for the x. Okay, so we're going to say 2 times 8 square root of 3 over 3. When we multiply by that whole number, all we can do is turn that into a fraction. And so we would really just multiply the 2 and the 8, which becomes 16 square root of 3 over 3. We don't want to double the denominator because that's not really multiplying it by 2. We want to make sure it's 2 over 1. And so that 16 square root of 3 over 3 would be our hypotenuse. So MN is across from the 30, so that would be 8 square root of 3 over 3. LN is across from the 90, our hypotenuse, so it would be 16 square root of 3 over 3. Okay, another one here. Let's go ahead and set up our chart. Notice that's what I do first every single time when I know what kind of triangle I have. I know the 4 square root of 3 is across from the 90, so that's where that will go. That's what was given. Doesn't look normal, so I know that I have to set those equal to each other. So 2x equals 4 square root of 3. We want to solve for x, so we'll divide both sides by 2. We know the 4 and the 2 can be divided, and so that gives us 2 square root of 3. And we just solve for x, so that's where that goes. Now we're going to take what we have for x and substitute in here. So let me change colors. So we're going to say 2 square root of 3 times the square root of 3. We took all of that and substituted it in for x. So our like terms here are the numbers under the radical. So we would say 2 square root of 9. But we know that 9 is perfect, so it's really saying 2 times 3, which gives us 6. So ML is across from the 60, so that would be 6. MN is across from the 30, and that would be 2 square root of 3. So please set up your charts, please set up your equations and solve for x, and this becomes so much easier. Let's look here at example 5. It says we have an equilateral triangle. We know that's a triangle where all sides are the same. One side is 11. They want the length of the altitude. We know altitude is another word for height. And they also want the area of the triangle. Okay, so let's draw our altitude. We know that creates our 90-degree angle and our 30, 60, 90. We know this would be 60, this would be 30. We know to set up our chart. X squared root of 3, and 2x. 11 is across from the 90, so that's what goes here. We know 2x equals 11. Divide by 2, x is equal 5.5, and that's okay to have that there. We're going to take that, substitute in for x, and say 5.5 square root of 3. Okay, so that is the length of the altitude. Altitude is across from the 60, so we know that the altitude has a length of 5.5 square root of 3, or even better would be to write it like that. Okay, the last little bit is asking for the area of the triangle. The area of the triangle formula we learned back in middle school was 1/2 times base times height. Okay, so the base of the triangle, and I'm going to highlight that, is right here. We know the length of that is 11. So we can say 1/2 times 11 times our height, which is across from the 60, is, you can use either one, either the 5.5 square root of 3 or the 11 square root of 3 over 2. I'm going to use the 11 square root of 3 over 2 and turn that into a fraction also. So I can multiply everything in my numerators and everything in my denominators. So 1 times 11 times 11, which would be 121 square root of 3. Multiply my denominators, which would be a 4. And then I would test to see if 121 is divisible by 4. And so it is not. We can't simplify it, and so we would say that this is our area. Okay, last problem. We look at this one here, and we see that not only do we have a 45, but we also have a 30. So we're going to use both of our charts to solve our missing problems, or missing side links. So we're going to start here on this triangle because it's the one with the information. So over here to the side, we're going to make our 45-45 chart. And if you forgot what those labels are, x squared root of 2. We know that the 8 is across from the 90, so we would put that here. That doesn't look like what we want it to, so we would set up our equation. X squared root of 2 equals 8. Divide by your square root of 2 on both sides. Can't leave that radical, so we rationalize. Multiply straight across. 8 square root of 2 over 2. That divides to 4 square root of 2. Okay, so we put that there. And we now know that across from that 45 in the other triangle, this would be 4 square root of 2, which now gives us a side link for our other triangle. So let's set up a 30, 60, 90. We know our labels are x squared root of 3, and 2x. If we go back to our picture, that 4 square root of 2 is across from the 30, so we're going to stick that there. And we're going to sub that in for this x and this x. So we have 2 steps here. So we have 4 square root of 2. I'm going to do the first one with the 60. 4 square root of 2, that's our x, times the square root of 3. Like terms are under the radical, so 4 square root of 6. That does not simplify, so that one is done. And we're also going to sub it in here for the 2x and say 2 times 4 square root of 2. Our like terms here are the 2 and the 4, and that gives us 8 square root of 2. So again, setting up both charts, which is fine to do, using one to help you find a side length of the other triangle. And so now let's answer the question. SG is the hypotenuse in the 30, 60, 90, so we look under the 90 in our 30, 60, 90, and that would be 8 square root of 2. LU is in our 45, 45 triangle, and that is a leg, so we know that it would be 4 square root of 2. And UG is across from the 60 in the 30, 60, 90, and so it is 4 square root of 6. So my biggest piece of advice is figure out what kind of triangle you're working with, set up your tic-tac-toe with your labels. If it's not one of those easy ones where you can just plug and go, set up an equation, solve for x. Remember, you can't have radicals in the denominator, so you may have to rationalize. Look back on some of these samples if you get stuck on the rationalizing part.